Hello everyone, welcome back to Geeks for Geeks. Myself Abhinav Awasthi. I am a DSA mentor at Geeks for Geeks. Today we are again with another mock DSA live session. And today we have Om with us. So yeah, Om will join shortly with us.
Hi.
Hi. Are you sure this course is just for 2499?
Yes, and you know this is the only course with this expertise across the world.
No way.
Yes way. Don't delay. Enroll now.
Geeks learning together.
Hi.
Hi. Are you sure this course is just for 2499?
Yes, and you know this is the only course with this expertise across the world.
No way.
Yes way. Don't delay. Enroll now.
Geeks learning together.
Hi.
Hi. Are you sure you can prepare for product based companies through this course?
Yes, sitting at home?
No way.
Yes way. Don't delay. Enroll now.
Geeks learning together.
Okay guys, so Om with us. Hello Om, how are you? Hi Om, I think you are mute. Wait guys, I think that Om is having some problem. We'll start in a while.
Yes.
Hey, what do you mean by a self paced course?
Well, the course material is available in the form of video lectures. And there are multiple practice problems that come along as well. So, you can access all of it anywhere, anytime. And they are available to you for lifetime.
No way.
Oh, yes way. Don't delay and enroll now.
Geeks learning together.
Hi.
Oi, So they give access to their job portal, Geeks for Geeks, for free?
Yes, complimentary with the course.
And you got your job through that?
Me and 15,000 others across the world.
No way!
Oh, yes, Wiz. Don't delay. Enroll now.
Geeks learning together.
Yeah, so Om is with us. Hello, Om. How are you?
Fine, sir. What about you?
Yeah, I'm fine, good. So, yeah, Om, are you excited for this today's live mock interview?
Very much, like literally very much excited. Even I'm
Yeah,
fumbling.
yeah, yeah. So, can you please tell me something about you, about your projects and your education which you are pursuing currently?
Okay, so my name is Om Umar Vaishya. I did my bachelor's in statistics from Banaras Hindu University. Afterwards, I'm here like in IDT pursuing my master's in computer science. I did two projects. One of them was a event uh, where we was creating a website where people can come and code. Like there was some code, wrong code. For that wrong code, people can search what should be the probable code or probable test case. For that test case, that given code will not work. So that is live. That project is live now. And second is machine learning project where I was using exploiting motivation of KNN, and using that I can predict
Hmm.
whether a location is safe or not. If a guy is, if he or she is in a compromised location, so he will be knowing like what is the security index of that location. So basically, that is security index project, and those both projects are
Fine.
live. Yeah.
Okay. Great, great. So, okay, Om. So we will start. So I have shared you a doc file, Google Doc file.
Yes.
Can you please open it and share your screen with us?
Okay. 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 So should I share the screen too?
Hello, Om. Hello.
Yeah. Yeah.
Yeah,
Yeah.
what are you saying?
Hello. Should I share the screen?
Yeah, yeah, yeah. After opening the file, you can share your screen.
Okay.
You can turn off any kind of notifications for privacy purposes.
Okay. So
Any problem, Om?
yeah, actually, it's saying that uh, actually like I have to allow the access.
Are you able to share your screen?
No, not really.
There's a share screen option at the
Yeah, yeah, I'm
bottom
allowing it. Yeah.
of your StreamYard. Just go and press that, and just go to the share screen option. Then you can easily share it.
Yeah. Okay.
Yeah, fine.
So with what? Okay.
Yeah, now it's okay. Okay, Om.
Okay.
So
Hmm.
now we will start with our mock DSA. Fine.
Sure.
So
Yeah.
okay. So Om, let's move towards the first problem. I will share your problem in this Google Doc only. You can just see that doc, and in that doc only you have to provide your solution. Fine.
Okay.
Okay. So the first problem is you are given with a singly linked list. Okay. This is the problem which is given to you. Okay. You are given with
Okay.
a singly linked list of size n. Okay. Your
Okay.
task is to left shift the linked list by k nodes. Okay. So just like
Okay.
we make left shift operations uh, in arrays, similarly we have
Yeah.
to apply this operation in a linked list. So let's take a
Okay.
sample test case, okay, and through that
Sure.
sample test case, let's discuss that. Let's take that for example, linked list given to us is 1. Okay, it is 1, 2,
Okay.
3, 4, and 5, 6, and then let's say null. So the length of this linked list is 6, you can say. There are 6 numbers in this linked list. Okay.
Right.
For example, the value of k is 2. Okay.
Okay.
So that means
Okay.
you have to left shift this linked list. You have to left shift this linked list 2 times. Okay.
Okay.
The
Okay.
last characters of that linked list of this linked list will come at the start.
Okay.
Getting? So now it
Yeah.
will be 5, 6, 1, 2, 3, and then 4, and then null. This type of shift operations we have to do. We have to do.
Okay.
Getting?
Yeah.
Yeah. So this is what we
Uh,
have.
okay. So can I see like I want to like remove some kind of ambiguity. Like what is the number of nodes are there? Like constraints are there? Like what could be a k value and how many nodes could be there?
Yeah, sure. I can provide you the constant here too.
Sure.
So the constant are like this. These are the constants that n is from till 1000 and k is from 1 to n obviously.
Okay. Sure. Okay. So I would like to take some like 2 or 3 minutes to think of it.
Sure, sure. You can take your time.
Okay.
Can you please zoom your dock so that it is visible to the other viewers too? Just zoom it with the help of Control plus. You can zoom your browser only. Yeah,
Now.
great. It's okay now.
Okay.
Yeah.
Okay. So yeah, I can do this by using. Okay. So okay. So should I explain it?
Sorry.
Hello. Should I
Yeah.
explain it? Yeah.
Yeah.
So okay, so initially I will try to create a like I will like there is k, so I will run a loop for k many times. So when my loop will be done, like my pointer, like I will run a loop k many times, and I will update my head pointer. Like there would be a head, like head initially head will be pointing to 1, right?
Fine.
So yeah, so I will run a loop for k many times, and my pointer will be updated k times. And after updation of k times, my pointer will be at a point where like for this example, after k times, like for 1 time, then second, then my pointer will be at 3. Okay, when
Okay.
I will run my yeah, then what we will do afterwards like all these things will be same, right? And then what I will do, I will disconnect, like I will disconnect these two things, and then again I will use this head. I will pick this head, and then I will connect this head to here. So I'll try to do something like that. Other ways are there, like, but it is my initial or my approach. So this way we can do this,
Got it.
like,
Got it.
yeah. So
Can
yeah.
you please can you please write a pseudo for it or a dry run thing something which can for example let's do that dry run for the value
uh
k is equal to 5. Let's do that for k is equal to 5. What you will do?
Okay, so k equal to 5. So like
Yeah.
k equal to 5, 3 or 6, like so. Like I think I forgot one thing to tell you, like not really k, like n minus k times, so that my pointer will be here at 5. Okay, then
Okay.
I will take all this part, and I will connect like the last thing will connect it to this thing. So not really k times, n minus k times. Otherwise we
Fine.
can, yeah, one more thing is there, like I will go to the last node, and then I will connect this last node to first node. Then like this way we can also do that, but this is really cool, like always running kind of solution, I think.
Can you please explain a dry run by taking this linked list only and taking the value of
Okay.
k as 5?
Okay, sure. So initially k is 2, then I will run a loop for getting the length of the linked list, right? So that loop will tell me the like that like I will try to head next, and then like I will count the length of the list. Okay, so
Fine.
the hand length of the list will be 6, right?
Hmm.
And then I will run a loop 6 minus 2 times. That will be 4 times. Then here, then here, then here, then here, and my head will be here 5. Okay, so one pointer will be at 4 and one pointer will be 5 to disconnect the connection. Okay, so this connection will be broken, and my head pointer will be here at 5. Okay, then my head pointer will be a 5, and now my head pointer will remain 5, and then I will again iterate to the last node of the this list, and then the last node will be like 6 is connected to the null. Then I will not like null will replace by the this location 1. So initially
So
my head will be
can
here.
can you please write a dryer code? Dryer means after every step of your algorithm, what is the
Okay,
result of your linked list? How your linked list will look like?
okay, so initially first thing first, like I will count number of nodes. Okay,
Okay. Just
then
scroll down the sheet. Yeah. Hmm.
yeah, I'll do that. Okay, so after counting this, I will run a loop or while loop or for loop, anything for for n minus k times. Okay,
Okay.
to like I will have two pointers, like let me write it out, like temp 1 and temp 1 and temp 2. Okay, so yeah, so I will run a loop for k minus 1 times. Then my
Hmm.
temp 1 will be at okay, so here will be at for this example that will be at 4. Okay, and
Okay.
temp 2 will be at 5. Okay, then
Okay.
what I will do, like I have a head initially, right? That is pointing to 1. Okay,
So in this
so these
case, you are assuming the value of k is 5, na?
no, like value of k is always 2. That will always 2. This n is the number of nodes in the like length of the list.
Fine. So you are
Okay,
taking value of k as 2 in this diagram, na?
yeah,
Fine.
always k will be always same one. So
Fine.
this is temp 1, this is temp 2, and this is head. Okay, so I will my temp 1 after k many times, after n minus k times, my temp 1 will be at 4, right? And
Fine.
temp 2 will be at 5, right?
Hmm.
And my head will be at 1. Then
Hmm.
now what I will do, I will again from temp 1, I will again from I will what I will do, I will do this temp 1 next, sorry, next will be null. Okay, so the connection will be broken. Which connection? This connection, the connection between these two
Got
link,
it.
like here.
Got it.
Okay,
Got it.
this connection will be broken. After was, yeah, okay, so after all I will again run a loop, while loop. Okay, I will again
Okay.
run a while loop, so that yeah, so that my like temp 2 next is null until this is not reached, this condition not reached. So for while doing so, my temp 2 will be at the last, my temp 2 will be at the last node. Okay,
Fine.
right, yeah. So what I will do now,
Hmm.
I will do this temp 2
So
next.
tempt 1 next is also null and tempt 2 next is also null.
Yeah,
Okay.
the
And
the
now you are
motivation,
making it to head.
yeah.
Okay.
So if
Fine.
you see this all this process, then you can find it like temp 1 next is null. Because why? Because we have broken, this is because of we want to break the
Uh,
chain.
yeah, but there is a thing I want to just confirm that currently your
Okay,
temp 2 is 5 na,
yeah,
and you are
yeah.
making your 5 next to head.
After running like this condition, you like here I will run a
Okay,
while
it
loop.
is while loop. Okay, till
Yeah,
then. Getting,
yeah,
got it, got it.
yeah,
Fine. Means then you will reach the last node of the linked list, na?
yeah, exactly.
Okay, got it, got it. Fine,
Yeah,
fine. Okay, so I think
yeah.
that I have got the approach what you are thinking. Can you please write just a quite pseudo code and then we can discuss on the complexity of your
Sure,
approach.
sure. Okay,
Just take
okay.
a link,
So
just take a node of the linked list as head node as the
okay,
node head, and the
okay.
value of ksk only, and just make a dry run. Sorry, write a pseudo code.
Yeah, right, right. Okay, so what I will do, first thing first. Okay, I will try to like uh, and suppose this is a node, okay, I'm saying is it is node only.
Currently, the value of both the temp tar is equal to head. Fine.
No, not like this temp is not initialized. Yeah,
Okay, okay, fine, fine.
yeah.
Got it.
Okay, so
Okay,
now I have my count.
okay.
Okay,
So this
now,
count will basically store the number of nodes in the linked list, na? The length
right,
of the linked list.
right.
Getting.
Okay,
Okay,
okay. Now I'll do while, like, again I will try to initialize my like temp2 is equal to head.
please scroll
And
down so that.
okay, okay,
Yeah, got it.
okay. So now what I will do, while, okay, so wait a minute, int x equal to mm, that count minus k. So while x minus, okay, like suppose it's minus.
Hmm.
So I'll do, yeah. So here temp one is equal, temp one is equal to 2, and then temp 2 is equal to temp 2 next. When we will come out the loop, our pointers will be pointing to 4, and my like temp 1 will be like, yeah.
Okay.
Okay, so
Hmm.
now we should break the connection. So I'll do what I'll do, simply I'll do temp 1 next is equal to uh, mm, basically null. Okay, so okay, so now again I'll do while temp 2 next, and simply I'll iterate over the list temp.
Hmm.
Okay, so our temp 2 has the very last node. Okay, so we will what we will simply do here,
Hmm.
we have to do one more thing, like
Hmm.
have one more node,
Okay.
answer node. Okay, answer node is equal to temp 2, because temp 2 is at that the point, like that conversion point. Okay, so now what I will do, I'll do simply temp 2 next is equal to head. Okay, and now we should return answer. Before returning, I should also do one thing, because case you like as the constraints were there, like k could be range from 1 to n, right, number of nodes, right?
Okay. Mm-hmm.
So
Yeah.
wait a minute. Yeah,
One
I
to n.
should, yeah. So 1 to n means like k could never. Okay, so it's okay if k was like, if k could be greater than n, so then there might be case where whole conversion would be there, then again we are converting it, but that is
Hmm.
not the case here. Yeah,
Yeah.
I think
In
we
that
should,
case, we can take a mod of with
yeah,
n. Yeah.
right,
Got it.
yeah,
Okay. So can you please just again scroll and show me the code?
yeah. Should I shrink
Yeah.
it?
No. I have got it. I have got it. Yeah. I have got it. Okay, so Om, can you please make a discussion on the complexity of this code? What
Okay.
will the time complexity and space complexity for this given code?
Yeah.
Hmm.
There is no such space is used because some pointers are used, some temp pointers, three pointer, I think three pointers, temp one, temp two, and that answer pointer. So complexity is basically constant. As far as time, sorry, space complexity is complex. Yeah, space complexity is constant, but I think time complexity it is. We are like finding first the length. So order of one would be there. Again, k n minus k times we are iterating is it, so n minus k, and then again like that small part, that small part would be k times. So here I'm writing it here. So okay, so space is not that much, space is order of one, I
Yeah,
should
I have
say.
got it. I have got it. Oh,
Yeah,
it is a constant you are saying, no? Fine, fine.
yeah,
And time is
but
off, and if there are end nodes.
yeah, so initially this n for counting the length, and then n minus k times for getting at that point, then again k to get the last node. So effectively it is, uh, yeah, you can say it's order of n effectively. Yeah,
Got it, got it.
yeah.
Okay, got it. It was nice what I was expecting. Solution was that only. Great.
Thank you.
So now let's move towards the next problem, I think.
Okay.
So I will just, you can just scroll down and I will add the next problem. Okay. Yeah. So I hope that you can now see my cursor.
Yeah.
So this is the problem number second, which is that you are dealing with a binary tree and you have to find a maximum path from leaf to the root of that binary. Okay. Let me
Sure.
also add a test case, a sample test case for you, so that you
Actually,
can
your question is not here. I am not able to see it.
just scroll it down. Where are you currently?
Yeah, sorry. Yeah. Yeah, okay, got it, got it. Should I shrink the screen? Like I am not able to see it.
Okay, okay.
Okay. So could you please guide me how to shrink it?
Can you please move up? It is okay. Can you please scroll up? It will be there.
Yeah, 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 yeah. It is here. It is here. It is here.
Yeah, yeah. So this is the problem, You can see that
Yeah.
the problem is that it is a very simple problem statement that you are given with a binary tree, okay, binary tree, and you have to find a maximum sum path from a leaf
Okay.
to root of that particular given binary tree. Okay. For
Mm-hmm.
example, in this case, you can see if you can see my cursor. So in this case, you can see now that.
Yeah.
We have this binary which is there are three ways from because there are three leaf nodes in this binary tree. If you can see, there are three
Yeah.
leaf nodes in this binary tree. The first leaf node is 8, which has the value 8. So the
Mm-hmm.
first path from leaf to root is 8, then minus 2, then 10. That is the
Mm-hmm.
first path. That will sum up to 16. The second
Mm-hmm.
path is from the leaf nodes minus 4. That will from minus 4 to minus 2 to 10. That will sum up to 4. And the
Mm-hmm.
third path is from the leaf 7 to root, that is 7 plus 10, 17. So the maximum
Right.
of these three paths will be 17, the maximum sum.
Right.
So the
Right.
answer is 17. So that
Yeah.
is what you have to find for a given binary tree. You have to find the maximum sum path from a leaf to root.
Yeah. Right.
Yeah. Is
Okay.
it okay? Is the problem clear?
Yeah. 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 Actually, could you please tell me what will be the answer for this tree?
Yeah, you can just ask.
Like this, like two sides are to one minus five.
Hmm, hmm, hmm.
Yeah. So
So
what
for
will?
this, the first leaf node is 2, you can see. So from that
Yes.
2, we can reach to its parent, which is also 2. And then we can reach to the root node, which is 7. So total sum will
Okay.
be 11 for this first leaf node. Okay. The second leaf node is minus 9. So from minus 9, we can go to 2. And from 2, we can go to 7. So the overall sum will be 0. Then for the third leaf node, which is minus 1, we will start from minus 1 and we will just reach the root, that is 7. So the sum will be 6. So out of these three sum, which is 11, 0, and 6, 11 is maximum. So the answer will be 11. Have you
Okay.
got it?
Yes. Yes. Uh, I would like to take some time.
Yeah, sure, sure, sure.
I think I'm done with this. Yeah. Should I explain it?
Yeah, sure.
Okay, so what we will do, we will use recursion, right? So we want maximum path. So maximization is like kind of optimization. So we should optimize at every level, right? So what I will do, at every node, I'll ask recursion, like give me the maximum possible path from here. Okay. So suppose we are at -2. Okay. So from -2, we will run two calls, left call and right call, and -2 will be informed like what is the maximum path after this -2. So like recursion will tell like recursion will return this 8 and -4, and then -2 will be decide like yeah right, 8 plus 8 is maximum from here, then plus 8 plus -2 will be returned from here, and at 10 we will have 6 and 7. So 10 will be deciding like yes I have 6 and 7, then 7 is the maximum, and then 7 plus 10 it is equal to 17, and then 17 will be returned. So this way we will proceed, right? I think this would work.
Okay, okay, fine. Got
Yeah.
it, got it. So can you just write quickly, because you have got this solution very fast.
Yeah.
It's good. So just quickly write the pseudocode too.
Okay. So suppose it's our main function, right?
Yeah.
Let's say it's okay. So let's int function solver or max path, something like that. We have suppose no tree root. Okay, so we have tree root, right? Name as root. It's our main function. We have root. Okay.
Yeah, let's say that you have the root node, and yeah, root node is sufficient.
Yeah,
Yeah,
okay. So
yeah,
what I
root
will
node.
be doing, like if I will find it as null, if it is null, like root is null, right?
Yeah.
So simply we are something where there is no data, right? So we should return from here as a zero, because no data means no sum, no subtraction, no addition, right? So
Yeah,
I'll return
got it,
zero.
got it.
Yeah. So but there
Okay,
might be a case which is a like this root could be a leaf node. So left will be null,
okay,
and that too right also should be null for leaf node, right?
okay,
So if these two conditions are matching, that's when it's a leaf node. Then
fine.
return root value. Suppose value is the root data, or I should say data. Okay.
Yeah, got it.
So now these two conditions are there. So okay. So mm, okay. So at any node, right? At any node, what we will have what recursion will be doing. Recursion will be simply returning something, right? So suppose so like int a. Okay. So if like at this node left subtree exists, okay, if uh, root left, if root left is there, then let me say something, int a equal to 0.
Okay,
P to 0. Okay. Okay. So if left subtree is there, then A will be max path
Hmm.
of what? Of root left.
Okay.
Okay. Similarly for right. Okay. Okay. So if these two exist, some at some cases like left exists, only right exists, right? Some cases
Fine.
both exist. Okay. So what we will do, we will return like this root value. Okay, root value along with the maximum which has been given by the recursion, right? This root value plus
Got it. Got it.
yeah maximum of yeah a
Fine.
comma b yeah. So
Okay.
this way we can return the maximum path at this level. Suppose we are at level some level. Okay, so
Hmm.
this is
Hmm.
the root value plus max of a comma b. This is the maximum possible value which we can get from this level, and we will pass this to up level, like from where this recursion has been got, right? So
Fine.
this will
Fine.
return
Fine.
this. Yeah, I think this should work.
Fine. 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 Okay. Okay. So can we have a discussion on the complexity of this code?
Sure. Some complexity of the code is like order of uh, let me write the recursion tree. Sorry about that.
No, no problem. Take your time.
Space will be not there, right? Like stack space will be there, order of n stack space for recursion calling, like we are calling at.
Yeah, if you are let's tell me the both the cases. If you are considering the stack space or if you are not considering the stack space.
Okay, so if the height of the tree is h, suppose, right?
Fine.
So
Let's
like
say that
for
the number of nodes in that tree is n and the height of the tree is h. That is given to you. Let's say.
yeah, so if height of the tree is h, then order of h will be space. Okay, and order of n will be time, I think. Yeah, order of
Yeah.
n will be
Okay.
time and yeah.
Fine. 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 Great. I was expecting the solution which you have told was a good one. That is what I was expecting, and it is okay. Okay. Sure. Sure, Prasant. If you want to be the part of this mock DSA, so you can just fill out the form which is given in description box. Okay, Om. So now let's move towards the uh, next problem. Okay, and it is
Okay.
so just give me 2 minutes so that I can share the problem with you. Okay, fine, fine. Okay, Om. So just scroll down. I have added a new problem for you, a new question. Is it visible?
For an array of integers, you can perform.
Yeah. So for an array of n integers, what we have to perform? You can perform two moves on that array. Okay. In the first move, what you can do is that you can choose an integer, and then you have to add it to your score. Okay. So
Mm-hmm.
you have to add it to your score.
Mm-hmm.
Then what you can do? You can discard either the left partition of that array or either the right partition of that array. And let's say that you have to perform this k times. To perform this thing k times only. K will be given to you, n will be given to you, the array will be given to you. You have to find a maximum score. So let's take an example. Okay, let's take an example. And also, if I will just say that the error, for example, AI is the element of that array. So AI will be positive and negative both. It will be positive and negative both. Okay, it can be positive or it can be negative. Got it? If we talk
Yes.
about the constant of n, so n will be from 1 to 10 to the power 5. Got it? And
Mm-hmm.
the value of k will be between as 1 to n. Got it?
Yes.
So now let's take an example also. Let's take the value of n is 6 and the array given to us is, let's say, okay, this is the array given to us. And let's say that the value of k is 3. Got it?
Mm-hmm.
Okay.
Yes.
So now what we have to do in this case, the answer will be, the sum will be, okay. So what we will do first, we will take this element 6. Okay. So 6 will be included in our answer. Sorry, not here. Let's write it here. Okay. Then what we will do? We will take the right side of this according to, or let's take it like we will take the right side of the 6 and we will discard this part. So now this is the right side. Then from this array we will take 10, we will add, and again we will discard the left side and we will take the right side. Then from this array we will take 7. So our sum will be 23. This is how we will do. Let me just tell you one more explanation, so that it will be good for you to understand. Okay, just give me. Uh, okay, so that is what we are going. Is this test case clear or not? Is this one clear?
Not really.
Okay, okay, no problem. Let me just take another. Okay, the value of n will be 6 only. Let's take another, which is 4, 6, minus 10, okay, minus 1, okay, 10, and minus 20. Fine. This is the array. And let's
Okay.
say the value of k is 4. So
Mm-hmm.
what you have to do, you have to make two operations. The first operation is that choose an index and add
Mm-hmm.
it to its store. Then what you have to do, you have to either discard the left portion of that array or either the right portion of that array,
Okay.
of that index basically. Okay. So what
Okay.
we will do, the first what we will do, we will take uh, 10 as an index, this index number 4. So
Okay.
let's take our score here. So this is our
Okay.
score. Our score will be 10 currently.
We
Now,
are we are taking 10 because 10 is maximum, right? Initially.
no, you can take any of the,
Okay.
that is not correct, that you have to take maximum. For example, in this case, in the last case I was taking 6. Okay,
Right.
basically we have to make the sum maximum. We
Right.
have to
Right.
do, and the next topic is that you can then, after choosing this 10, you have to either delete the right hand side of the array or the left hand side. For example, I am deleting this right hand side,
Okay.
and also this 10 too, that will also be
Mm-hmm.
deleted. So now this is
Mm-hmm.
the remaining. Now from this array also again I have to take some element. Okay, so let's
Mm-hmm.
say I am taking 4, or
Okay.
let's say I am taking 4. Okay, so now 4 will be there. Then
Mm-hmm.
there is so for example now I have removed the left side of this 4, which is there is no left side, so we will not
Okay.
remove anything, and
Mm-hmm.
we will take the right side. Okay, so this 4 will also be removed. Now
Mm-hmm.
from this, let's say I have taken -1.
Mm-hmm.
Okay? Let's say I've taken -1, so that
Mm-hmm.
minus is taken, and this will be removed, and now we will consider this one, this case, and let's say
Okay.
that we have 6 now.
Mm-hmm.
So the overall sum will be 10 plus 4, 14, -1, 13, 6, 19.
Okay.
Got it? So
Mm-hmm.
initially there were 6 elements, but we
Mm-hmm.
have taken these 4 elements from that. So if
Mm-hmm.
I just again write the initial array, so it was something like 4, 6, -10, -1, 10, and -20.
Mm-hmm.
So we have to take I index, I element, and then we have to either delete the right side of the index or either the left side of that index. That is what we have to do.
Okay. Score should be maximum, right?
The score should be maximum. Is the problem clear now? Is it
Yeah,
completely
yeah,
clear?
yeah. I'm getting it.
Okay. I hope it is clear to all the viewers also. You are solving the problem.
Yeah, yeah, yes, yeah. Yes.
Yeah, fine.
I'm having my time.
Take your
Yes.
time. Take your time.
Yeah. I think I have a solution.
Yeah, sure. You can tell.
So as the question says, like what my intuitions are saying to me, like we can pick any element, right? So suppose I'm gonna pick four. Initially, I'm picking four, and then I'm pick while picking after picking four, I can call like I can have two calls, either to left, like either to leaving all the left and only having right, right. This one, or I can pick only four and I can leave all these things. In that case, I will be having only four as a
No, no, no,
answer. Okay.
not 4. Not 4. At that
Okay.
place, you will have the left side of the 4, at the left part of the 4, either the right part of the 4. You have to remove that element which you have taken at the index.
Only
That
that
element you have
element,
to
right?
add it. That element you have to add in your score, and you have to remove that element. Means basically after adding that element in your score, you have to either take the right part of the array or either take the
Mhm.
left part of the array. For example, for this 4, there is no left part of the array. There is only right part. That
Mhm.
is what we have to do. Either the right part or the left part.
Okay, so what if initially I gonna pick six? So after picking six, like what all the available options are? Like I have
After taking 6, you can take your 6, add your 6 in the score. Then either
right,
you can take the right side of the array, which is -10, -1, 10, -20, or the
yeah.
left side, which is just 4. That is what you do.
So like after like suppose I have picking six, right? So
Yeah.
after picking six, like I will be available with all these elements. Either
Not
like
always. Either the right side all the elements or the left side all the elements.
yeah, that's what I'm saying. Like either I can
Yeah.
go this side or this side, right?
Yeah. Yeah. Yeah.
Yeah. So let suppose I'm picking four, right? Okay.
Fine.
So after picking four, I have two options. Either I can go with this or I can go with this. In four case, like there is no this way. There is no left.
Yeah.
So
Getting.
eventually I have to go this way, right?
Yeah. 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 Yeah.
But
Got it.
in case of 10, either I can go for 20 or I can go for minus 1, 10, 6, 4.
Yeah.
Right?
This is the problem. Yeah.
Okay, so yeah, so initially what I will be doing, like I will be doing like I will be preaching to all the element, like reaching or preaching to all the elements. Suppose
Fine.
initially I will go to four. Okay, so because there is no left at the four, then I'll have four. Then I'll have a recursion call or something like that. I'll call this part and I'll ask my recursion that give me the answer of this part. Okay, give me the answer
Okay.
of this part. Okay, then a recursion will give me the answer of this part. Again, what I will do, like this part is done. Like I will be having four and then answer of this part. Okay, I will
Okay.
store it in some kind of temporary variable. Suppose recursion has given me x, then x plus four is the answer for four as of now, right? Then what I will do, I will go to six. I will have six. I will have two calls. Call to four side and call to left side or on this side.
But you have to take the k number of elements. The score will be of the sum of k elements from the array.
Okay, okay.
How
For
you
the
will manage that k? That there will be the sum of k only. Uh, if you can write a pseudo code just a little bit or just a dry run, I'm getting that thing. Or you are that you can make recursive
I
call
will,
for the left
I will
side or the
yeah,
right
but I can
side.
manage it. Like I can manage this. Like I can have a heap or something like that for maximum
Okay,
expansion.
okay,
Yeah,
okay, okay. The heap, na fine, fine, okay, no
yeah.
problem.
But the
Got
problem
it.
being is like complexity will be pretty much enhanced. So that way,
Yeah.
like I don't think it will be solved in a
Uh,
quarter of an time.
First, please write the pseudo code or something of dry run for your approach which you are thinking, and if possible, also think of a more easy time complexity and space because it is possible. If you are not getting it, I will just give you some hint. But first, take your own time to think of that. A more good time complexity maybe because I think recursion will take uh, uh, omega of 2 to the power n.
Right? Yeah. Actually, yeah.
Yeah, that will be a very complex time complexity. So if it is
Yeah.
possible to perform it in a less time complexity, and also that recursion will take the space of stack, and if
Yeah.
you are using heap, then the heap is the space will be there also. So
Yes.
if we can perform this in a less time and space less complexity, if you can think of that.
I'm trying.
Otherwise, if you are suitable with this problem, also you can write a pseudo code for that.
I can write code for this, but I don't think like it will not run. So I think I should go for better complexity.
You can think of it. You can if you want, then I can just give you just some hints.
That is great, but yeah, I'm thinking about it. Like I'm feeling like DB could be used here because like
Okay.
what we are doing, we are doing the same thing at every call. At every
Yeah.
index, we are doing the same thing. So like suppose like when I will be drawing the backtracking tree. Sorry. So suppose I'm at six. Okay. So this six will ask this thing and this thing, right? So this must like this thing, like what is the maximum for this thing or what could be the maximum answer like for this reason. So and also when like I'm at four. Okay, so this will also be asked like six along with six, but this reason too, right? Here this
Okay.
thing.
Okay.
So I
Okay.
think something could be managed over there along with indexes.
So using DP, you are saying.
Yeah, actually, like blend of DP or something like that. Like
Mhm.
suppose I have k calls. I can have k calls. So this is like I here I, and this is suppose j, and along with k equal to, so at some point k will be reduced. K will, if k is four, then at some point k will be three or something like that. So like suppose I'm at six and I want this much. So what I will be doing, like I will be uh, along with I and J and K. Like I will be this for this part. I will be 2 and J will be like 5 and K will be suppose K. Let's say
Okay.
so. This will be stored somewhere. Like once I will calculate this, and then I will store it somewhere. And then again, suppose like somebody is asking for this much, like same case somebody is asking for this much, so this much I have stored, and this is also known, this 6 is also known. So what I will do, I will like in like suppose like I know this much, okay, and somebody is not asking for whole, like I know like I know like suppose that is too large, and somebody like I we have stored 1 comma 10, like 20 comma 30, and also 10
Fine,
comma
fine.
20. Yeah,
I'm
so
getting.
10 to
I'm
30 we
getting.
know it, yeah, like yeah, so
Yeah,
10 to
means you
30
are
we know
saying
it.
to basically divide these problems into some sub problems and then call that sub
Exactly.
problems. No? Got it, got it.
Right.
I've got it home, and that is a good approach if we go towards that thing. But Om, this problem is solvable by a more easy technique, and I'm just giving you a simple hint, which is can we
So,
solve it by the time complexity of of n log n?
okay.
Yeah. Okay, just think, Om, that we
Yeah.
want our
I
score
got
to
it.
be maximum. I hope that
Yeah,
you
I
have
got
got it. Okay,
yeah.
okay. So yeah,
Okay,
what we have
so
to.
okay. Okay, so like I'm guessing it, like tell me whether it's right or wrong, okay?
Yeah,
So
yeah.
suppose I'm taking 10, right? Okay.
Fine, fine.
So like suppose I've sorted the array. Suppose.
Okay.
Like sorting will disturb the combination, right? So
But we don't care about combination actually. We
right,
are
right.
thinking
Because
about
like
that.
if I'm taking 10 and then I'm taking 10, then I'm taking 4. So 4 will be somewhere like either it will be at left or right or
You
somewhere.
don't have to
So
output the operations which you are doing. If I will ask you that, please output the operations like the first index you are taking and
right,
like that.
right.
But that is
Yeah.
not what I'm asking. I'm just asking the maximum score.
Yeah. So after sorting, like run a loop for k many times, I got it. Run a loop for k many times, and somebody might think like that, like I'm disturbing the operations, so I'm disturbing the indexes. So the answer for that question is like we don't really want that thing.
Yeah, we
What
don't
we have
care
done,
about that.
yeah, we don't care about that because like we have 10, right, and somebody is saying like you have sorted the array and 10 will be like ascending or descending order, something like that. So 10 will be suppose in increasing order, like decreasing order, so 10 will be at the top, like at the very first index. Okay, so after 10 there will be 6, so then so someone should say after sorting the combination will be disturbed, but the thing is we don't really care about the combination because even after disturbing the combinations, that index will always be somewhere like right or left or right, so that is always in the array. So I don't think like I'm explaining it right correctly, like
Yeah, yeah,
I'm
yeah.
getting,
Got it. Got it.
I'm not able to explain it
No, no,
actually.
no. It is. It. I have got it. I have got it.
Yeah,
Yeah, and that is what we can do. We can just salt it, and I hope that for
yeah, it's
this drying is not required. We have to just sort the array. And for
yeah.
salting, I think that you know the time complexity. So just tell me that what is the time and space complexity?
Time complexity will be simply order of n log k plus order of n log n, n log n for sorting, and the space will, I don't think it's it is in place sorting, so I don't think there will be any space because
It will
like
be no
inbuilt space
option.
is not take any
No
time
option.
like space. Yeah,
Constant.
yeah.
Fine, Om. Great. So this was
One answer for this, like this thing, like combination will be disturbed, will be like all the combinations will be disturbed, but that 6 will be always left or right to something. Okay, so that will be always in the array, and if you clearly see, then we want the maximum things, like we have 10, then we are going for 6. For going for 6 we are discarding this thing, okay, but this thing is always there, right? All the things are
exactly.
always there. Yeah.
Yeah, you have got it. You have got it. Yeah, that is what we have to do.
Yeah.
Great, great, Om. Great. So I think that yeah, we have done with this problem, and
Okay.
now it's time for the feedback time, Om.
Yeah.
So Just scroll down to the next page. There I have written feedback. Just scroll down.
Okay. Thanks for it. Feedback.
Yeah. So yeah. So
Okay.
I talk about the communication skills. Okay.
Yeah.
So for communication skills, you need some improvement. So
Okay.
the thing is that when you are writing your code on
Yeah.
your notebook, okay,
Yeah.
that time you are not communicating with the interviewer, with me. That time you are just
Mm.
writing that give me some time, I am thinking of that. Uh, so just try to communicate with the interviewer while, for example, if you're thinking the approach, if you are just writing it down it on paper, then
Yeah.
also you can just tell a little bit at what you are thinking, in what way you are thinking, so that it will be fine na
Actually,
Om.
there should be a connection between interviewer and
Yeah,
the
yeah,
like.
yeah.
Yeah.
That
Right.
is what we have to do on. Fine. So
Yeah.
in that place you need some improvement. Okay, just whenever you are making anything, you are thinking of a new approach, you are thinking of a new implementation, just communicate and try to tell something to the interviewer. Fine. So
Okay.
in the place of this communication, I will give something 7 to 8 out of 10. Okay.
So okay.
If I will just rate your coding skills, so your coding skills were good. It was great. Like the
Ah,
first problem, that rotate linked list problem, there you have done good. After that, the minus tree problem, you have just think of the approach quite fast, and the implementation was also good. What I was thinking, and then for this last problem, yeah, it was a quite tricky problem, I can guess, and
yeah.
but yeah, you have got it at the end when after that hint. So yeah, if we talk about the coding skills, it is good, and I can give it something 8 out of 10 after that. Okay. And similarly for implementation skills and your explanation skills, how you have explained the things, or the dry run, the implementation of the code, that was also good. So for coding also, I will just give it is not like I can give 7 to 8, but yeah, 8 is good. And for implementation too, 8 will be good, I think. So it was good, means that the way you have implemented that recursive code for the second problem, and that pointers code for the first problem, it was good. So it will be something also like 8 out of 10. And if I will just write overall, so overall your performance was good, Om, and it was like 8 out of 10. Yeah, that is what I can give a feedback to you. Just a thing from my side, just a suggestion from my side, that try to basically, now you can unshare your screen. Now you can unshare your screen.
Sorry,
Okay,
I didn't get it.
you can unshare
I should
your
stop.
screen.
Okay.
Yeah,
Okay.
yeah.
Okay.
So yeah, so that is what you can do, that just be in a communication with the interviewer, just try to say, just try to tell that what you are thinking, just don't write out that thing.
Right.
And always try to make a dry run of your approach, because the verbal communication is less effective than the dry run. So always make a dry run, and try to tell, or write basically what you are thinking, how your approach is going to be. Fine. Overall, Om, it was a great experience with you. I hope that you have also liked the session.
Yeah, it was my first ever interview. Like, I didn't appear in any kind of interviews ever since. Like, I'm preparing for DSA and all. It was nice
Okay,
experience,
great,
basically.
great, Om, great. So
Mm.
thank you, Om. Thank you for joining.
Yeah. Mm. Thank you.
Okay, guys. So that is for today. If you guys also want to be the part of this mock live DSA, so you can just fill out the form given in description box, and you can also get a chance to be with here with our mentors and have a live mock DSA interview. Thank you, guys. Thank you.